Cool, we'll kick off. So who am I? Co-founded Pump Security a few years ago, so that's what I do day to day, so DevSecOps, pen testing, consultancy. But I'm also a Python developer, security guy, and all-round geek. And Pump Security, got open source tools and stuff, come and talk to us if you want. Cool, so really I guess I want to start with how did this all come about, the little badge stuff, and there's a concept in security called Badgelife. I don't know if you've come across that. And these sort of, can you see these at the back? These sort of, yeah. So these sort of badges is what you'll see at DEF CON. You go out to DEF CON or Black Hat. There's a big culture around. Well, this is not going great. I'm going to stand here. So if you go to DEF CON, this is DEF CON 25, someone's badge hoard. So these sort of badges are just really prolific out there. Here's another set of random flashy badges. For me, in IT, we quite often deal with abstract concepts, and it's difficult to see what we do. You know, if you ever try to explain what you do to your sort of parents, then you probably feel the same way. And I'm also not very creative. I can't draw or play music. It just doesn't come naturally to me. So this is quite a good creative outlet, whilst also being on the periphery of what we do as an industry. And the way that these badges tend to work is really quite accessible. So, as a starter for 10, we have a coin cell battery, just like the ones on the back of your badges, and they connect to an LED. You don't need to put any components in the way. There's enough internal resistance in the battery to make an LED light up and not blow the LED. So, from a circuitry point of view, they're very simple. So, I thought I'd have a crack at doing these a few years ago, and we've got some examples of ones I've done. Then it starts to get a bit more complex though. So if we want to control LEDs and make different LEDs flash, then we have to have slightly more complex circuits. The main driver, and it's the same for your badges here today, is a tiny little microcontroller called an AT-Tiny 402. So you end up writing quite horrible looking C code, or ChatGPT writes it for you, but you're into this interesting space where you've got this little bit of electronics, and it's very entry-level starter electronics, and then sort of starter-level, entry-level C code. So it comes together quite nicely for beginner sort of stuff. The only downside is when this code goes wrong, you get no feedback. I've done a talk on this at BSIDES Cheltenham about exactly how you would use tools to create PCBs and create the code and all that sort of good stuff and programming microcontrollers. We're not going to cover that in this talk today, but if you wanted it, it's on YouTube. You can go and grab that. So what I want to do in today's talk really is say, how do we get to this point, right? So how did I go from not doing stuff a few years ago to creating these? If everyone's not aware yet, these are soil sensors. So you've got your flashy mode, but when you get home today, you can shove this in a plant at home. There's little instructions on the back for calibrating it, and then when it needs watering, it'll start flashing red. So a bit more involved than a normal conference badge. So how did we get here? So my first badge was the Cyberman, and one of those is going around today. So I wanted to do a badge around the sort of Cyberman aesthetic, and that sort of, the Cyberman leads itself to badge design really because it's a full metal front, right? And that's what we can produce on the badges really easily. So this was the first attempt. I'm not sure if you can see it at the back. Does that show a little bit? So the idea was that you'd have, rather than these sort of LEDs, eyes, you'd have big LEDs on the front, right? And that's basically because I didn't know how to do anything different. So this is the circuit. I'm not sure you'll be able to work this out, but that's the back of the first badge. So my first ever attempt. And what didn't dawn on me at the time I made it, but it did as soon as I tried to put it in, is that line there that goes across that pad is the positive side of the battery. And then that middle pad there is the ground of the battery. So as soon as the battery goes in, it creates a nice little short. So that badge never works. So I had to sort of cover it up with a bit of nail varnish. And then when you put the eyes in, they sort of stuck out the badge a good centimetre, and absolutely ridiculous. So that didn't go very far as a badge. So then I thought, oh, how about we start playing with the NeoPixel LEDs, right? So these are the things on the current badge. So at this point, I don't know anything about badges, so I start looking out on Reddit and stuff, and is this stuff even possible? So some person 4 years ago, Thick Noodle Salad, asked, can we use NeoPixels with coin cells? So coin cells run at 3 volts, and these are meant to run at 5 volts. And coin cells don't have that much output compared to like an AA battery. But for badges, they're a nice form factor. So anyway, can you do it? Of which the answer is no. I wouldn't bet on them working at all below 3 volts. It would not work on 3 volts, and the coin cell would not provide enough current. So the general consensus was it wouldn't work, but you've got to test these things, right? That's the culture we've got in InfoSec, is the data sheet says no, but reality can say yes. So you end up doing nonsense like this. So this is the very first prototype of a badge, breadboard in it, but also this sort of stuff where I've literally got LEDs, shoved them on a board, and now I can find a way to test them at various voltages. And you go and buy one of these things off Amazon. So this allows you to dial the voltage and the amps. So now I can go, will it work at 3 volt? Will it work at 2.2 volt? Will it work if I drop the ampage? What happens if I put too much through it? And essentially it would work. So now we get into this sort of prototype. So this is another badge. Again, it's the Cyberman. I don't know if you can make it out of the back, but rather than a battery pack, we've got probes on the battery casings, and we can put variable voltages through those. I screwed up the circuitry, so I had to put this like horrible wire on it, because half the things are back to front. But that's that journey, and this is what the Cyberman ended up being. So the Cyberman in the middle works, and all these other ones don't. So it's quite a painful journey, and every time you make a mistake, it takes you 2 weeks for the boards to come from China before you realise, or I don't know if it's better or worse, sometimes you realise a week in, you're still waiting for your order, and then you sort of have an epiphany in the shower, oh, that's never going to work. So it's quite a painful feedback loop. And I think in IT, we get quite used to quick feedback loops. Like we're quite happy to make mistakes because it surfaces quite quick and then we fix. You don't really get that with this. It forces you to slow down. Cool. So I've got a Cyberman badge at this point. And then BSIDES Cheltenham, in 2023, I'm on socials and they say they got a Back to the Future thing, right? So I'm like, this Cyberman, if you sort of stretched it a bit, we've got a DeLorean. So let's go and do a DeLorean batch. And that's where this came from. Now, this itself introduced a few challenges. So the DeLorean's got this, if you ever seen Back to the Future, parts of it light up blue. So this rail here, on the bottom would light up blue. The problem is if you're shining blue light through a yellow board, it diffuses really quick and you don't really get the blueness. So a lot of the game here, this is the first prototype of that board, and there should be one dotting about, is basically a board with different size LED slots, and then we can try all the different LEDs and see which one produces the best light through the board. And then we order actually about 3 or 4 different boards from China of different depths because we want to try and make it sure the light diffuses enough. But actually, it's not. If the board's too thick, the light diffuses so well you can't see the damn thing. So there's a bit of a mix to play there. So that was the BSIDES Cheltenham DeLorean, and that was the end result. So we had the blue lights coming through, and then the headlights are all different colours. It worked quite nicely. We had a bit of a mini game on it, and that's where we shine that blue light through. So the following year, BSIDES Cheltenham had a UFO theme, and again, if you get a Cyberman and sort of stretch it and squeeze it a little bit, we have this. So this was like absolutely noddy. There was no rejects apart from I ordered some prototypes and then they didn't like these landing legs. They said they looked like some sort of like sci-fi udders. So we ended up with a new board without the udders. So you'll see one floating about, smaller as well. They wanted it slightly bigger. It was a fairly smooth process. Cool. So by this point, BSIDES Cheltenham, I'm fairly happy that I can do a fairly decent badge game, right, for conferences. And then BSIDES Newcastle is a local con, right? So I'm in Northallerton, company's in Northallerton. BSIDES is our closest one. And they've got this like really quirky plant thing, right? Like what the BSIDES Newcastle I came to was giving out succulent plants. So they're like, let's lean on the plant vibe. So I get in touch with Ben and Ryan and I said, yeah, Punk would love to come and do some badges. And they send these sort of pictures. So this, plant pot geezer here is the mascot of BSIDES. It's okay, what sort of badges can we do here? And I was a bit probably overly ambitious. So my first thought was, well, if it's plant vibes, can we make a plant sensor? So can we work out if your soil's too dry? And you can get these things off Amazon, right? So you, 2 probes, you whack it in the soil, and you should be able to work out if the soil's dry or wet. That's the gist of it. So can we get this geezer, give him big sort of golden legs and pop him in a pot of soil? That's the plan. Here's the science behind it. The way that sort of mechanism works is, this is everyone's electronics sort of basics here. We've got a voltage applied to a circuit, we've got two resistors, and in the middle, that voltage, the value of the voltage on this V out, stand by, that green circle, will fluctuate depending on the value of these two resistors, right? That's what we call a voltage divider. So if we replace one resistor with soil, and that soil resistance changes based on its moisture content, then as the soil resistance changes, if the top one is the same, then this voltage changes. And we've got a way of measuring the resistance of the soil, and therefore its moisture content. That's the science. There you go, look, add some water. So then we get into testing. So this is one of those Cyberman badges that are floating about. And I was trying to work out what's the best way of measuring the soil moisture. You know, should it be longer probes, shorter probes, far apart, close together? You know, rather than actually like research it, I figured I'd just solder some wires in front of this Cyberman, shove them in a pot of soil, and then take loads of measurements of resistance between the wires, right? So that's what's happening here. So that's all good. But then the reality is, within a few hours of passing current through those plates, the electrolysis kicks in, and it takes all the top off it. So now, at this point, you can no longer get a reading. So whilst it did look to work quite nicely, the badge just basically destroys itself when we do the testing, right? This is a bit of a drama, so you go back to the drawing board. Internet's like, oh well, can't really use those. You have to coat the surface in something, galvanise it essentially. So I thought, oh, what about, there's a bit of a harebrained scheme, number two. He's got his arms out, we'll give him some wires, and we'll hand out a bucket of galvanised nails at the door, and then you can just go skew those into a pot, and then it'll be able to do it, right? And that'd be great. But then I thought, even for BSIDES Newcastle, a bucket of galvanised nails going out to people, it's probably a bit stupid to be sticking people's legs and things. So that wouldn't work. So then, harebrained scheme number three, and this is where I should have really stuck a pin in it, is capacitive sensing. So how can we measure the moisture of soil? I know what you're thinking, why are you still going down the soil route, right? I don't know. But anyway, so so how can we measure the moisture in the soil without putting electricity directly through it and therefore causing that problem? This problem has been solved, and it's on Amazon for like £1, right? Capacitive soil moisture sensor. And you think if something's on Amazon for £1, it should be fairly easy to do, right? But then it turns out it's not. So here's a circuit for a capacitive soil sensor. And I'm trying to basically remove all this stuff because I don't want to solve it all and just get away with what is the absolute minimum we need to test it. So let's talk science there for a second. So the way this works now is we are going to try and connect two pins together. Connect two pins together on the controller, and we put a voltage out of one pin and read it on the other, right? So we turn a pin on, it's wired to the next one, and we read it. And there's a bit of a resistor in there to slow down electricity getting through. Okay, that's the theory. And what happens is, when the soil is connected to that pin, it acts like a little bit of a battery, and therefore the voltage won't immediately go up. It creates a curve, right? That's Science 101. And the idea is if we put terribly pixelated water into the soil, then it becomes a bit bigger of a battery, and now that rate of charge will be different. And therefore, if we measure in the rate it charges, we can see how good the soil is. I know what you're thinking, this is absolutely nothing to do with conference badges, is it, Simon? But it's the path we're going down. So, I didn't have a prototype to test that, hence the first version of the badge, which is not too dissimilar to the one you've got today. 2 weeks later, that comes in the post, and this is what it turns up like. And it's not a trick of the projector, I completely messed it up, so there's no art on it at all. It's off to a good start there. And then you can't really see, I don't think, but it's basically soldering a load of probes to the badge at this point to work out if it will work. We end up with this sort of weird system in the living room for approximately 3 months in various guises of plant pots with sensors in, going to a laptop, some serial outs, and we're just measuring the rate of charges. We'll go into that in a second, but we start doing this. We won't work this out, but the reality is it didn't work. So as we start to now measure this, and we're measuring the rate of charge appears in sometimes to be slower when it's wet, but not all the time. It was different times of day. I was doing it for about 4 hours trying to work it out, and it was basically too close to my laptop monitor, and the interference was trashing it. Different parts of the day would cause it. It was just a bit of a nightmare, really. So, what I then worked out as well is when I connected it to my laptop to get the data off the chip, the chip is powered by the coin cell battery, but to get serial to work, you have to have a common ground. So you connect the ground to your laptop via the serial port. And now, when the laptop's connected, that throws interference down the ground line, so your ground's moving whilst you're trying to measure a voltage difference. It's an absolute nightmare. So, you end up with this chunky thing, which is a breadboard with a load of relays on. And what we're trying to do is get this to measure the soil moisture whilst it's not connected to the laptop, and then connect to the laptop and take the reading in a fairly automated way. So, this becomes a reality. We've connected it to the laptop. Interference is kicking in. So, we cut the lines with a relay. The device then measures it. Then we remove the break and we read it in the laptop. And we do that over and over and over. Soil takes an extraordinarily long time to dry if you haven't got a plant in it. So, just really painful. And that's where this device comes in. So this allowed me to do this over, days, weeks. And it just sounded like I had some sort of weird robotic cricket living in my living room. So we're doing that now, and it still doesn't quite work. What we see is this same problem. We're doing sampled readings, but one time it can be completely different to the next. And there's no real obvious pattern. So then I start looking at open source research and what other people are doing. Someone's actually got an open source one of these, which is where I got that schematic from earlier. But the obvious thing, really, when I looked at it on this picture, is that their probe is like this probe. There's a middle ground pad. You can't really see it in this. So we go back to we order a new one back from China, and now we've added this middle sort of lobe, and that allows this battery element to form. Some people say you don't need it. It really works for us though. But the feedback of drying out soil is still too slow. So now I have to buy a greenhouse off Amazon and a dehumidifier, and then the whole thing sits inside these shelves and we're drying soil as fast as we physically can. Because what happens is you put the badge in and you go, oh, this is great, the soil's dry. And then you water it and the values change. You go, this is great, I'm detecting water. And then at some point over like 2 or 3 days it stops working and you have to sort of work out what you've done wrong. And that feedback loop of drying soil is absolutely horrendous. So this ends up in the living room for a good while. And then we switch to this mode. So what we talked about before is we just went to that battery charging. Well, some clever individual figured that if you put a signal through it, rather than just charge it and try and measure it, you put a signal through, and then if it doesn't fully charge because the battery's bigger, and they won't fully discharge because the battery's bigger, we end up with a slightly different value on average, and that's easier to work out. And that's what you're seeing in this. So then you start getting the oscilloscope on the badge, and this is our charging cycle. I can't remember if this plant's wet or dry at the moment. It looks like it's wet. It gets squashed when it's wet. So you end up with this pattern. And it's better then, how do we programmatically read this pattern on a microcontroller? Cool. But then what we also see, which was the first time I'd seen this and kind of makes sense, is the bit that we're trying to measure is this. And this is on each of those lines. So whatever this background noise is, I don't know if it's me broadband or me microwave or whatever, causes our signal to ride on another signal. And actually from the microcontroller, it couldn't tell when this was happening, the numbers would be off. So then we need to work out how to eliminate that. Here's the geezer in the greenhouse, chilling. So we test and test and test, and it still doesn't work, and I'm sort of getting a bit fed up with it. And then it sort of works out that it's this static resistor we've got at the start. So if this is really high, we get super good granularity, and that's why we were using it to start with. So when the soil is wet, it takes absolutely ages to charge, and we can measure that really easy. And when it's dry, it doesn't. So that's really good. We've got a good sweep. When the resistor is smaller, the effect of the soil is less because the battery charges faster, if that makes sense. The problem is that high resistance also means that there's so little power coming through to charge the battery that external noise can charge the battery as well. So that now seems obvious, but that did take me about a month to realise. So what we do there is we pop the resistor off and we put a variable resistor on, and this allows me to just put a screwdriver in and change the value of resistance, and then it goes back in the greenhouse, and there's two running side by side, and we just keep testing and testing until we find the sweet spot, which on these is 6.8 thousand ohms of resistance. Tweak is back in the greenhouse, and then finally we get to a point where it works, and this was only probably mid-August. I'm on the Discord, I'm like, it actually works, like, this is great. I could sort of loosely tell when it was in water or not, it just wasn't working as a soil sensor, so for a little bit of a time I had an idea that we could use this as a game, right? So it'd sit there and he'd go red when he's angry, and you'd dip him in a cup of tea or something, and then you'd unlock a new flashing mode. So we turned it into a bit of a Tamagotchi. But that was, insane. So thankfully it worked. So here he is. I don't know if this is going to play. The first time first prototype really working. He comes out and he starts flashing red when he's out of the water, and then you pop him back in the water and he goes back to sleep. That was just so satisfying. I'm glad you all really appreciate that. So we're back in there, we're tweaking the codes now, and then we had a sunny day in Yorkshire, so he was out in the garden for a bit trying to dry that soil. And we get graphs like this. So what we're trying to do here is work out what that tolerance should be. So what we're seeing here is we'll come back to this. This is a video of some guy on YouTube, and it shows this signal we were talking about getting squeezed as it's getting, in this case, in our case, when the soil's wet, but he's just touching the probe. So I don't know if you caught that, but essentially that's exactly what we're measuring here. So when we get this signal in, the code is measuring it. Yeah. So when the soil's dry, we get this nice big peak, and ideally it should be square. Pin comes on, pin comes off. But we end up with this sort of sawtooth, and the wetter the soil, the bigger the battery, it gets squashed down. And that's what this graph's showing us. So when we start to sample that data, we end up with a low point, a high point, and then the difference between the point. If you imagine, so we get three things, and what we actually care about is the difference, because the low and the high can move depending on battery voltage and stuff. So then you start writing lots of weird code to sample it as fast as you can. Lots more graphs, lots more tweaking. And then there's just one more piece of the puzzle. So at this point, we've got a working badge, and we can measure soil. But what you want to do is put this in a pot of soil. The more I say this, I'm aware of how insane this process has become. But we want this to be able to put in the plant and last like a year or so, right? It's no good if every 2 weeks you've got to change the battery, because at that point you can probably just like touch the soil and work out it's a bit dry and add a bit of water. So we want to be able to the battery life to last. And when you're doing confidence badges, this might actually be relevant if you want to do your own badges, is you need to work out what the power consumption is, right? So if you're running on a coin cell, this in flashing mode will last you maybe a day or two. In soil mode, you easily get over a year out of it. And when it's turned off, the microcontroller stays on, but it will last probably a decade. And this is exactly how we do it. So I used to have this trash oscilloscope, I've got this fancy electronic one, and what we're seeing here is when the pin comes on to start measuring in this instance actually, when the soil's too dry, the LEDs flash red. What we don't want to do is the LEDs flash red for a day and then it dies, and then your plant dies because you're like, then it's fine. So what we're doing here is working out exactly how long did the LEDs come on. So here it says 15 milliseconds, right? So we can see the LEDs voltage shoots up as the microcontroller turns it on and flashes. So now we know that they're on 50 milliseconds, and you're into a game of working out what's the minimum you can flash for, but a human eye picks it up as a flash, right? If you pick 50 milliseconds, it's only on for 1/20th of a second, but it's enough for you to recognise it. So we flash that every 4 seconds, and now we've got a ratio of when it's on to off. And then we use a very expensive multimeter to work out, it's about 150 quid, to work out how much power that's using at that time, right? So you see the multimeter that can do that. A bit of maths just times those together, and these should last about, if you don't, they'll last longer than your plants. If you put this in a plant and it starts flashing red, you get about 2 months out of it. I think if you don't water it in those 2 months, your plant's dead anyway, so you might as well stop the battery. But in sensing mode, it'll last years. We added some shiny teeth to it, added the instructions on the back, tested it some more, because it turns out that if you add shiny teeth, it might change some of the way that capacitive circuit's working, because you've added big play on sort of antennas essentially. But that was fine. Add the flashing modes, solder 220 of them, program a load of microcontrollers, produce a very punk version, and that's it. You've got yourself a conference badge.
Wow, complicated. And so for the book, how many months have you had random plant soil? Well, you didn't plant it, soil and electronics lying all over your living room? Because that would be murdered.
Yeah, it was bad. Because the wife had these 2 olive trees, and the pots were just absolutely brilliant for building a soil sensor with. The olive trees, I mean, they were fairly dead anyway, but the olive trees were a great antenna, so they had to get hacksaw out of the pots. So that was probably the worst bit, but yeah, it was the sort of electronic cricket noise for 2 months. It was a bang problem.
Yeah, I would have liked it.
Yeah.
Any questions? Because we already have a question straight back.
So when you're prototyping, you use going on board
I think the minimum order is 5. I tend to get them in 10s. There's always that hopeful glimmer that they will work. And they don't, but yes. So 5 or 10. Once you order over 20, I think the shipping starts to get a bit weird. At least I use JLC PCB, which is the only one I think does popular print.
How many iterations of boards did you have to order for this badge?
I think this badge was 4, but a competent engineer would have ordered less. Yeah.
It's been 4 given the number of times you had problems.
Yeah. So most of the problems are changing this level of resistance towards the end. It's like back and forth, which is one little component.
Any further questions? Oh, sure.
How have you achieved the level of tolerance for these projects? And why would she not say, see you did it?
I think over time she's given up. And strategy I can work with.
Why?
Yeah. I think, yeah.
Is this another Marvel question? Right, okay.
Do you have any DeLorean buttons?
Yes, we've got a few. What we do, as an individual and as a company, we try and be open source. So, I've been a bit busy to get the new chapter 1 on GitHub yet, but Shelton 2023 2024, so they're on GitHub, so the code, all the things, you can just go to JLC and give them the Gerber and order 5 of them. It's all on there, you can do it. Or, yeah, speak to us. We haven't got any on our stand today, but yeah, you can get some DeLoreans or new codes. Awesome.
Further questions? Some sort of people chat.
Yes. Sorry, I forgot that was good. Right, yes. So, so this is this is SAO header. If you're in the backside, you'll recognize it. I think it's now called simplified add-on, but it has a more happy sort of S word at the start. That exposes the 3 volt on the ground, so when if you want to play these, and then it also exposes the UPDI port and microcontroller, so you can flash your own code through those headers. We use that during development, and then we also be unpopulated because people and solvers are harder. And every single jump we can get away with not doing, we use Sigma. But yes, you can put a thing, or if you went to DEFCON, this would work as an extension to the DEFCON badge.
Any further questions? Then a round of applause for Simon.